So I'm going to talk about considerations for deployability for additive construction. Um, so, as the looking at, I'm part of the DoD, so we look at military problems, whether we're doing humanitarian disaster relief or we're doing military operations. We're thinking about deployability. How deployable is this? Can we fit this in a container and ship it overseas and obtain materials locally and reduce the amount of logistics that we need for making this a viable technology for the military. And so we look at various degrees of research in this area. So we've done several demonstrations around the country. We're now looking overseas. And so, moving from laboratory to field, there's general considerations, including local resources and what structure is going to be completed, what method we're using, and the local constraints, because you may be constrained on what you can do based on the local environment. And then more specific considerations, we're talking about construction type, whether we're doing I'll talk about this, but the construction type, the printer type, all the way down from pump materials, material delivery, shift length, various degrees of items that we're discussing. So we're looking at the printer system. Essentially it's software printer, pumping system, mixing system, extrusion system. We have our own system that we've developed, which is lightweight, can be teared down quickly, can be assembled quickly. It was developed with a cooperative research and development agreement with Caterpillar. I can't discuss too many of the details about the printer, but it's very easy and mobile to use. We look at materials, the concrete materials, the base, the materials that go into the concrete, the printable concrete, and we've kind of keyed it down to these simple things to make it a printable concrete. Just varying the additives, you can achieve a printable concrete. And then you can use various types of reinforcement. We've done some testing with those, and we always try to adhere for these types of testing with ASTM testing standards, as was mentioned in the previous presentation about testing standards and trying to maintain those to show something that's constructible. When we talk about materials and getting them on site, talking about doing reconnaissance ahead of time. As the military, we're going to go on site or have whoever's on site deliver it to us to be able to assess those materials, because the quality of our materials is going to affect the quality of the print material. Because if we have large aggregates that we find in sand, as you can see from the upper right picture, or large aggregates that we find in our pea gravel, that's difficult to pump those through a pump system. And so we're not able to, so we had to find unique sieving solutions on site for that in these scenarios. And these were actually delivered to us ahead of time, and we actually assessed these materials, and they were still delivered on site with these large aggregates. And so anything that can go wrong will go wrong, and so we have to find solutions for that, and that's what, as the U.S. Army Corps, that's what we do. And so doing material reconnaissance is very important. In terms of cement, we can obtain it. It's pretty easy to obtain cement anywhere around the world, but we're also looking at other alternative materials, printable materials. But most of our research has focused at this point on cement. Reinforcement, we can usually obtain that pretty easily. We try to stick to traditional reinforcement because we are trying to adhere to current technologies, because that's what's going to be available to us at the time. And as we transition to maybe some more unique reinforcement methods, such as was presented earlier, we might be able to adapt those down the road. But right now we're trying to stick to more conventional methods. Material quality. So we're looking at different tests for material quality, trying again to We've adopted the unconfined compression test that's typically used for soils to assess the material and how it can how it holds its shape. And then we've also looked at rheometer tests and print stability. So printing a test print that and seeing how stable it is as we print up kind of assesses the material. One thing I want to point out is if you look at the stress growth curve, you can see the difference between a mortar material and a concrete material. The mortar material, after it reaches its peak, it loses its torque very quickly, whereas opposed to a concrete material does not. It sort of maintains that. It does drop slightly as would be expected, and as it should happen with a printable material, but we have more maintaining of the torque value. And I'm going to try to jump through these because we don't have much time left. There's a need for setting realistic expectations. We have looked at this kind of test that, the 24-hour building that has been said before. We were seeing can this really be done? So we did around-the-clock operations where we printed our second. This was actually our second building that we printed, and we looked at the time that we actually were printing it, and we developed this equation of delayed time equals the elapsed time minus the print time. So the delayed time is actually the time that either you're resting because you're not able to print on the next layer yet because you're waiting for it to gain the strength or the stability, or it could be a delay due to we stopped for a while, sent Marines home, and then they came back and they did the rest of the print later. And so total time we printed this within 48 hours, just the walls of the structure. So that doesn't include the roof, that doesn't include any finishing or MEP or anything like that. So it's we want to make sure we set realistic expectations as we move forward as an industry, because if we can produce the building in 2 weeks versus 24 hours to the consumer, for the commercial industry, it's not that much of a difference. For the military it is though. So we're trying to push the envelope here and trying to see how fast we can do things. And one thing that helps is the stability of the material, because we have typically printed with material with aggregates, which does help with the stability of the print. Construction methods: print in place, pre-print, essentially, similar to cast in place and precast. We've looked at reinforcing strategies, tying to roofs, tying to the foundations. We've implemented these techniques. They're fairly straightforward. You can follow typical precast CMU type connections, as well as doing interlayer placement of reinforcement. And one of the things with this technology is geometry versus reinforcement. We can get unique geometries that enhance the structural performance. We're looking at some structural testing where we actually have this wall that has a zigzag or a V shape on the bottom and goes to a straight wall on top, and we're able to get 2.5 times stronger strength than with just a straight printed wall. And this has vertical reinforcement. This one actually does not have any horizontal reinforcement. However, typically we do use horizontal reinforcement, but we wanted to look just at the vertical reinforcement. And so we were able to get structural loads. And this is part of the validation testing that we did for the second building, similar to what the last presentation mentioned, where we actually do all of the testing ahead of doing a print, because we want to make sure that it's going to meet what we expect. Because as you may not know, the U.S. anything that's deployed and constructed oversight the designs do follow U.S. code requirements. Whether it's done that way on site is another story, but they're supposed to follow US code requirements, and they're designed that way. In summary, the summary of what it takes to do deployment can be really summarized into the logistics plan and the safety and risk mitigation assessment. So we've gotten really good at these safety risk mitigation assessments and doing training and of Marines as well as soldiers, because we do most of our demonstrations with military personnel. We train them, and then they do the printing, and we're there basically as the subject matter experts to make sure that things are going smoothly. And so, these are just some of the key summaries for this, when we look at deployability, what we're looking for. And then last thing I want to just kind of show what we've done. We can do a widespread custom infrastructure applications where we're looking at anything from buildings to bridges to fighting positions, culverts, barriers, things like that. So I just kind of wanted to show that. And then in the bottom center is our team photo.